learning activities, you'll see the course is divided into different modules. And the modules are not quite corresponding to the weeks. In particular, we're going to try to get through the first 5 modules in 4 weeks. So the pace is going to be a little bit faster than 1 module a week, but I'll try to make it clear to you which tutorial exercises you should be doing in which week. Now, within each module, there's these little pages, and then usually there's some tutorial questions and also some lecture slides. So the lecture slides will be posted before the lecture, and if there's a video, if there's an echo recording, I'll try to post a link to the echo recording here. So these are the lecture slides for this week. So this is about the foundations of artificial intelligence. So, right, so as I said, the course materials are available through Open Learning. My name's Alan Blair. I'm the lecturer in charge for this course. Hello. I do research in artificial intelligence and machine learning, mainly neural networks, and also some evolutionary computation. That's my email address and my office. So the lectures are going to be on Fridays from 10 to 1 here in the John Clancy. Now the tutorials, if you have a Friday tutorial, it'll begin today. So how many of you have a Friday tutorial, Friday afternoon tutorial? Okay, your tutorials will begin today. Everybody else, your tutorials will begin next week. Now, the reason we're doing this is because Friday of week 9 is a public holiday. It's Good Friday. So because we're missing out on that Friday of week 9, we've decided that the Friday people should start in week 1 to balance that out. So if you've got a Friday tutorial, you may have to try to, it's very important that you try to keep up with the material and perhaps watch some of the lectures ahead of time so that you know what's going on. And there will also be prologue labs, which will start today and will continue into week 5. And so I'll say a bit more about them as we go along. Okay, now these are the planned topics for this course. I should probably mention the textbook first. So the textbook for this course is this one, Artificial Intelligence: A Modern Approach, by Russell and Norvig. I believe it's available in the bookshop. Has anyone managed to obtain a copy of this book? They're out of stock. Okay. Well, we are going to be it's a very, very thick book. It's got you couldn't possibly cover all this material in one term. It would take a whole year to cover all the material in this book. However, we will be following the first 8 chapters quite closely. Okay, so if we go back to these planned topics, these first few topics follow the chapters in the book in order. Okay, what is artificial intelligence? Classifying tasks and agents, path search and heuristic path search, games, constraint satisfaction, logical agents of first order logic. So this is going to quite closely follow the textbook. After that, we'll have a selection of other topics. So we'll talk a little bit about machine learning, learning and decision trees and neural networks and some reinforcement learning. Then we'll come back and talk about uncertainty, and the very last couple of lectures will probably cover some machine vision, some topics of current interest, so like machine vision and deep reinforcement learning. Okay, what to do? So sign up to Open Learning through Moodle, work through this week's learning activities, log into your CSE account and start working through the prologue exercises. Okay, so let's have another look here. So just the way this is structured, if you click on each of these pages, normally there'll be a video associated with this. Now, when was it? 2 years ago when I taught this course, some two students came in and videoed my lectures, and they did a little bit of live editing, and I kind of edited them down afterwards to get rid of all the ums and ahs and so on, and I've chopped them up into little pieces of about 20 minutes each, and I've put them up on these individual pages. So I'm going to assume that you're going to be watching these lectures. So when we're here with the class time, I won't necessarily be covering all the details in class time. I'm going to be summarizing the material and having some discussion, and I'm going to expect that you'll be looking at these videos to catch the details of the various algorithms. So you can either watch them before the lecture, or you can go and watch them after the lecture for revision, but all the details are there in those lectures. Okay, where are we? Prologue. Right, so we'll be using a language called Prologue in this course. Now, why are we learning Prologue? Well, there's a few reasons. It's actually it's a very useful language for AI and search, and these kinds of languages have recently had a resurgence in popularity, but also we think it's beneficial for you to see an example of a non-imperative language. So for those of you in, that's funny. So for the undergrads, you mainly learn C and Python and Java. For those of you who are postgrads, mostly Python, I guess. And initially, so most of what you do in your program is these languages that are called imperative languages. Now, Prologue is an example of a different kind of language, which is called a kind of a logical language. And I think it is beneficial for you to see an example of this kind of language, okay? And I'll talk more about this as we go along. Where were we? Yes, the prologue. So, so you're going to be, so the prologue equally will be treated the same as the other topics, but perhaps even more so. So I've got recorded lectures about prologue. If I go back to Open Learning, it's got its own, if you click on this link here, lab exercises, this is all about prologue, and there's little lectures embedded in here. And so again, I'm going to be summarizing the material, and then you're expected to go and watch these videos and work through some associated exercises. And these labs are provided to help you work through those exercises. So some of you may be happy to just work through it yourself at home, which is fine, but if you'd like to get some help with it, you can come to labs at any of these times in the first, from now up until week 5, and there'll be tutors there, lab consultants there who can help you. And so this will start, the Friday one will start today, this afternoon between 4 and 8, and these other times will start next week. And I'll show you a link to those exercises. Okay, so I've shown you the recommended textbook. For Prologue, we have a sort of recommended text, which is Prologue Programming for Artificial Intelligence by Ivan Bratko. If you want to have a look at that, there's also, I've got a link, sorry I keep jumping around here, but Prologue, if you click on this first Prologue page, there's some information here about how to download SWI Prologue, and then there's some references here, and one of them is this. Okay, I'll talk more about that a bit later. Yeah. Now, there's some other references I'll mention throughout the course if you're interested in more detail on particular topics. So this is another example of an AI textbook. This is particularly about reactive agents and behavior-based robotics, and I'll mention others as we go along. Okay. Now, the assessment for this course, there'll be either 2 or 3 assignments. At the moment, we're planning 3 assignments, of which 2 will be programming assignments, and the other one will be like a written assignment that won't involve programming. But I'll say more details about that next week. But the assignments will add up to 40%, and then there'll be a final exam, which is 60%. And in order to pass the course, you have to you add these 2 marks together, you've got to get 50 out of 100, but you also have to get at least 40% for each component, so the assignments and the exam. And if you this is the kind of assignment that we might ask you to write. Now, plagiarism is taken quite seriously in this school. All work submitted must be your own work. The final assignment, you'll have the opportunity to do it in a group of 2 if you want to. So, discussing with other people how to approach the assignment and that sort of thing is, of course, encouraged, but you're not allowed to just copy someone else's code. If someone asks you to email them your code, just tell them no. And certainly you shouldn't be soliciting other people to write code for you on the internet or anything like that. So plagiarism detection software will be used to compare all submissions, and if there are sort of similar assignments from previous years, we'll compare against them as well. And if your code is deemed to look suspiciously similar to someone else's, then you'll be asked to come and have an interview and explain why that's the case, and it may lead to certain penalties and so on. So please avoid plagiarism. Now, if you take this course and you decide that you like AI and you want to do some other courses, then these are some options. I think this course is going to run in term 2. This one will probably be in term 3. I think that'll run in term 2. That'll be in term 3. So some of these run in term 2, some in term 3. You can check to see which is which. And if you're looking to do a research project or a fourth-year thesis topic, there are various topics available in AI. Apart from myself, there are some other academics in the school who do different types of AI who may be interested in supervising these kind of projects. Okay, so any questions about this administrative stuff? I'm trying to see how to turn the air conditioning on, but I don't seem to have any control over that. But I will look into that. Okay. Okay, so AI is a multidisciplinary area, and people have looked at it from many different perspectives. So going all the way back to ancient Greece, you've got the philosophers looking into this. What is the mind? Maybe the mind acts like a machine. Maybe knowledge is encoded in an internal language. Thought and reasoning, and what is consciousness. So these are the issues that philosophers tend to think about, and some of it's still going on today, some of these questions. And then sort of mathematics and statistics and physics and logic. So from the logical side, tools to manipulate logical statements, algorithms to find solutions to problems, complexity analysis of those algorithms, dynamical systems, neural networks, statistical pattern recognition, differential equations. All of these things kind of feed into AI as well. And then you've got psychology and cognitive science. So kind of introspection and experiments with... By the way, I should ask, is anyone here enrolled in a philosophy course? Or taken a philosophy course here at university? What about mathematics? Oh, you study philosophy? Yep. You did? Uh-huh. What about mathematics? How many of you have taken a math course here? Probably most of you. How about psychology? Yeah? So what was your first degree in? Linguistics. Very good. Okay, so you've studied quite a few of these related topics. Yeah? Okay, so the psychologists have ways of doing experiments on people and measuring their responses and so on. Linguistics, formal languages, computational linguistics, natural language processing, obviously very important. Computer engineering, building computers that can process algorithms faster, do them more parallel. Robotics, mechanical engineering. And then we've got sort of what might be called biocybernetics or neurobiology, so studying of the brain and trying to model what goes on in the brain. And, also neurology and psychiatry are perhaps linked to all this. So, people have come at this from so many different angles, and they all kind of see things in a slightly different way. Now, if we go back to the philosophers and think about theories of intelligence, in the ancient world there was this debate between rationalism and empiricism. And then Descartes famously wrote about the mind-body dualism, which is kind of connected with consciousness. Is the mind a separate thing from the body that interacts with the body? Is it an epiphenomenon of the body? And what is the actual relationship between the mind and the brain? Now, and then more recently, you've got psychology. So Sigmund Freud, most notably, he brought our attention to the importance of the subconscious, that there's a lot going on in our brains that we're not consciously aware of. underneath, and then what we're aware of is just kind of the surface, for the tip of the iceberg sort of thing. And behaviorism. So this was, Skinner did these experiments with pigeons in the 1940s and 50s, where he trained them to respond to a particular stimulus in a particular way. I should have mentioned Pavlov, who was doing similar experiments with dogs in the 1930s. Now, this rationalism, empiricism debate, I don't know for sure, but basically rationalism in very general terms says that, argues in favour of innateness, that our thoughts and beliefs are largely something that we're born with, whereas empiricism puts more emphasis on experience. So it's sort of in its extreme form, a child is born as a kind of blank slate, and then it can learn, it gains knowledge by experiencing the world. So there was this debate between these two schools for hundreds of years, until eventually Immanuel Kant wrote his Critique of Pure Reason, which kind of argues for some kind of compromise between the two. And there was this famous T-shirt about rationalism versus empiricism. Friedrich Nietzsche says to do is to be, Immanuel Kant says to be is to do, and Frank Sinatra says do be, do. Now, I think it's also interesting to look at artificial intelligence in literature. This is some classical literature related to artificial intelligence. And one thing you notice about this is that often most of these things have a kind of European or European or Middle Eastern origin, and apart from this Astro Boy, but there's often kind of the idea of a kind of dark side to the creation of life, So Pygmalion was a sculptor who made his sculpture came to life, but then he spent all of the time interacting with the sculpture and never talked to real people. Golem was a clay man brought to life. Frankenstein, Mary Shelley's Frankenstein. So Frankenstein created what turned out to be a monster by stitching together parts of dead bodies and then animating it. But in the end, it turned out badly, and the monster came back and attacked him. Pinocchio was a puppet that came to life, but also has a kind of dark side in a way. Rossum's Universal Robots is about the effect on the economy. The robots basically kind of take over everybody's jobs, and then there's the life for the humans is not very good. And so the view about these things is often they emphasize the negative side, but interestingly, in Asian culture, particularly kind of Japanese and Korean culture, they have a more positive view of robots. So perhaps best illustrated by stories about the mighty atom, also called Astro Boy. So this is my this is my Astro Boy. So there's this question about good or evil, and when people have done surveys asking people whether they view robots as good or evil and what kind of robots they tend to think of, you do get this dichotomy that in Japan they tend to think about sort of Astro Boy and Gundam, and they think that robots are nice and here to help us. In the West, people tend to think about robots like the Terminator, and they tend to have a negative view of robots. Now, this is actually, I want to come back, I don't want to, if we have time at the end of the lecture, I'd like to come back and have a bit of a discussion about this, and you should definitely pick this up in the tutorials, because these issues are very topical these days. You know, we should discuss some more recent movies about artificial intelligence and what attitudes they reflect, and really what are the, you know, whether robots really are good or evil. So I think we'll come back at the end and discuss those things. Okay, artificial intelligence origins. So this is a sort of a summary of the early history of AI up until the first AI conference, which was held in Dartmouth in 1956. And it tended to focus on mechanical calculators and laws of logic. So Pascal and Leibniz were very interested in implementing laws of logic, and they thought that disputes could be resolved by just codifying everything into logic, and if two arguing parties could both see the logical, you know, could both be exposed to the logic behind something, then eventually they would come to an agreement. Unfortunately, it doesn't always work out that way. When we talk about games, I'll go into more detail about this. Wolfgang von Kempelen built this artificial chess-playing machine, or a machine that pretended to play chess. It was really a kind of trick. But Charles Babbage was inspired by that mechanical Turk and in the 19th century, and tried to design a mechanical computer. He didn't have enough money to build it, but his designs were sound, and these people already were starting to think about the implications of artificial intelligence. And then you've got sort of an emphasis on logic, so the calculus of logic, predicate logic, first order logic, and so on, and then you get to the Dartmouth conference. Okay, now at this point, I think I've done a fair bit of talking, but I think it's useful if I turn this over to you. What would be your answer to the question, what is intelligence? Yes, would you like to tell us?
I guess it would, where you have learned background, probably define intelligence in different ways. I learned psychology, so I probably define it a little bit different to maybe a mathematician or maybe someone who's computer science.
Okay, so you learned psychology. So how would you define intelligence? Consciousness.
Learning from past experiences. I don't know, it's probably how you define how it's been tested.
Right. So if a robot wasn't conscious but appeared to behave the same as a human, would you say that it was intelligent?
Well, I guess that is a form of intelligence. It's really in the grey area.
Mm-hmm.
Humans couldn't say
That's a good point. I'm just repeating this in case it doesn't get on the... Yeah, humans aren't that intelligent either when you think about it. Yeah, I suppose. It's all relative. Who else has an opinion about this? Yes? Solving problems, yeah. Find your own problems, yeah. So that's interesting. So not just solving problems that are given to you, but figuring out which which problems are important to be solved. Yeah. Yep. Seeing connections between things. Yes, that makes sense. Yeah, I think someone defined mathematics as the ability to call different things by the same name. Maybe that's part of intelligence too, seeing connections. Yes?
The ability to reason and create and be able to solve problems based on learnt experience and then apply that to a problem that has never been faced before.
Okay, that's good. So learning and applying your previous experience to solve new problems. Yeah. Yeah, I like that because you're getting at the idea of transfer learning kind of thing, that people, if you solve one problem and then you're given another problem that's related but a bit harder.
Not related, but you
Yeah.
can program a machine and it can do an amazing simulation
Mm-hmm.
of intelligent thinking, but that was ultimately just that intelligence was given to it through its programming and
Right.
through some learning. But if you were to throw a machine into a completely different environment that it had never seen or know how to deal with, and it was able to reason out a solution that would
Okay, so adaptability.
come into something that's not like a human would be. You throw them into an awkward situation where they never experienced something like that before, or even like an artistic creation that it's not based on anything anybody else has done before, but they come up with something completely unique.
Yes. No, I think that's very interesting. Yeah, because, it's very interesting you raise these points because a lot of current machine learning is kind of very rigidly defined, and often it's like you have a task and then you learn that task. But I think probably, if you want to ask what the next frontier is, it may be things like this kind of flexibility and also like the transfer learning and open-ended learning. Yeah, creativity. Yeah, that's very interesting. I mean, as one example, you train a neural network to recognize digits that are written as black text on a white background, but then if you show them white text on a black background, often they just totally fail because they haven't been trained on that. Yeah.
The neural network's actually quite good at adapting to those sorts of circumstances, depending on how many neurons they've got. But if you were then to take that same neural network and throw something like, say, the characters in Chinese or something, would it have any idea of being able how to figure what that actually meant? And then could it communicate?
Good question. I think it would have to be, it becomes a more difficult problem, definitely. Yeah. Okay, so some good ideas there. I mean, part of the reason I'm asking this is to lead into this Turing test. So this, most of you probably have heard of Alan Turing. He was like a code breaker in World War II and made enormous contributions to computer science in general. But one of the things he's known for is this paper that he wrote in 1950 where he talks about the possibility of artificial intelligence. And this is what he came up with. So he said, well, I can't really give you a definition of intelligence, but I can tell you how if someone came to me and said that they had an artificially intelligent system, I can tell you how I would try to test whether that's true or not. So he came up with this idea where you have a human interrogator and they're communicating with a witness through a teletype system, and some of the time they're communicating with a computer, sometimes with a human, and they're given a certain limited amount of time, after which they have to try to guess whether they're talking to the human or the computer, right? Now, I think it's interesting to go, and he said that he predicted that this test would be solved by the end of the 20th century. We didn't get, I don't know if we're quite there yet, but we've made considerable progress. Now, I think it is interesting to look at this. This is an extract from Turing's original paper. He gives an example where the witness has been asked to study some sonnets of Shakespeare and then is asked some questions about it. So this is this famous sonnet that begins, "Shall I compare thee to a summer's day?" So the interrogator says, in the first line of the sonnet, it says, "Shall I compare thee to a summer's day? Would not a spring day do as well or better?" And the witness says it wouldn't scan. So the point here is that the response given by the witness is very short, but it's by giving that short answer, the question you've got to ask is, what do you need to know in order to give that answer? So in order to be able to give that answer, you have to understand that poetry is divided into syllables. Poetry is divided into, poetry has a metre, it's divided into feet and to syllables, and you need to have a two-syllable word to fit into that slot. If you put in a one-syllable word, it doesn't make sense. So it doesn't really work. So you need to know all of that in order to give this answer. Then he says, how about a winter's day? That's got two syllables. And the witness says, well, nobody wants to be compared to a winter's day. So what do you need to understand in order to give that answer? Well, you have to understand that a summer's day is something people view as positive, that they want to be associated with, whereas a winter's day is considered something negative, that nobody wants to be compared to a winter's day. Then he says, would you say Mr. Pickwick reminded you of Christmas? This is often, in a way, Christmas is a winter's day. Obviously, it's written from a northern hemisphere perspective, not here in Australia. I don't think Mr. Pickwick would mind the comparison. I don't think you're serious. By a winter's day, one means a typical winter's day rather than a special one like Christmas. So the witness is demonstrating that they understand the notion of typicality and exceptionality, and this is a very general concept. In general, birds can fly, but there are some birds like penguins that can't fly, and so on. So this is very clever because it kind of it's very open-ended. Yeah, this is different. We're talking a little bit about Jeopardy. This is actually harder than Jeopardy because with Jeopardy the questions are decided in advance and then you answer those questions. But here the interrogator has the opportunity to change their questions based on what the witness says. If the witness gives an answer which appears to show some weakness in a particular area, the interrogator can choose their next questions to focus in on that weakness. Yeah, so this, in some sense, it's a much harder task than Jeopardy. Now, in the 60s, Joseph Weizenbaum wrote a little program in a programming language called Lisp to try to, sort of the first attempt to try to solve this Turing test. And it was a very simple program based on pattern matching, but it did a reasonable job. It's called, in this case, the computer is pretending to be a psychiatrist. And so this is an example of a typical session. What brought you here to see me today? Oh, nothing much. I'm feeling a bit tired, that's all. Why do you think you're feeling a bit tired? Well, I've been traveling a lot and away from home. Tell me more about your family. So that looks like a normal conversation, but you can pretty quickly poke holes in it, and if you look on the open learning activities, there's a page where you can actually have your own ELIZA session and see what happens. So, you know, the trouble is my mother's ill, how long has she been ill? The trouble is my mother's Irish, how long has she been Irish? The trouble is my mother's poodle, how long has she been poodle? So it kind of exposes what's really going on here. The way this works is, the way this worked was it just, well, it would pattern match. So it would detect that the visitor said, I'm feeling a bit tired, and then it would repeat back what they said, and it would replace I with I'm with your, and a few simple substitutions like that. And then if you mention your mother or your father or your home or something like that, then it might come back and say, tell me more about your family, you know. And if it just had no idea what you were talking about, it would say, please go on. You know, so it sort of was good enough to fool people a little bit, but there wasn't really much behind it. And, but I should say, you know, if you want to look for something much more modern along the same lines, you could look for IBM Watson Deep QA. This system competed on Jeopardy a few years ago and managed to beat the humans. And I think there's a link to a video on the Open Learning website. This is just one example, so I'm sorry, you can't probably read this, but I'll read it out to you. Because it kind of gives some idea of the kind of problems that need to be overcome from ELIZA to have a proper system. So the question here is, in May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. And Watson has access to this huge database of stuff that's been downloaded from the web, and if a naive system or an early version of the system, when given this question, decided that this document was the most relevant, it says in May Gary arrived in India after he celebrated his anniversary in Portugal. So in a superficial way, this looks very relevant because they both mention May, arriving in India, celebrated anniversary in Portugal. So you might think that this is Gary, but that's actually not the right answer. So the real answer is Vasco da Gama, but in order to figure that out, you need temporal reasoning. You know, it says if 1898 was the 400th anniversary, that means it's something that happened in 1498, right? And then you need statistical paraphrasing or synonyms. Arrived in and landed in are the same, are synonyms. And you need geographical reasoning. It says India here. Vasco da Gama arrived in Caput Beach. Sorry, I should read this out. So it says on the 27th of May, 1498, Vasco da Gama landed in Caput Beach. So it uses the fact that Caput Beach is in India and that Vasco da Gama is an explorer. So putting all of this information together, it figures out that the correct answer is Vasco da Gama. And this was a few years ago, but a lot of work has been done on IBM Watson, and they're trying to put in deep learning and that sort of thing in here. So this highlights another kind of frontier, I guess, of AI, is the kind of these hybrid systems that integrate symbolic methods like this with neural networks and statistical learning. Any questions about this? Now, it's worth mentioning these critiques of the Turing test, or of AI in general. Some people have argued, most notably Rod Brooks, that the Turing test puts too much emphasis on abstract reasoning rather than low-level perception and behavior. The fact that it's by text through a teletype kind of encourages that sort of processing, whereas maybe what we should be concentrating more on is vision and robotics and, you know, being embedded in the real world. There's also a debate about general intelligence versus specific modules. So Steven Pinker wrote this book in 1997 called How the Mind Works. I actually highly recommend this book, even though I don't agree with his premise, because it's just a very well-written book. But the question here is not about whether intelligence can be achieved at all, but just are there general principles of intelligence that can be adapted to anything, or is the mind built up with a special vision module and a special language module and a special something else module all kind of tacked together? So that's another angle to this debate. And then there are people, and in a way I guess this is historical, but there have been people who argued that artificial intelligence would never be achieved by any method. Some people argued on the basis of Gödel's undecidability theorem. There's this Chinese room argument. I think there's a link to a little video about that. And this Dreyfus wrote a book called What Computers Can't Do and updated it in 1993. But I have to tell you, I've been teaching this course. I started teaching this course in 2007. So this is my 13th year teaching this course. And, you know, the shift in attitudes that's taken place over those 12 years is remarkable. So every year at the beginning in the first tutorial, I ask students, first of all, do you think human-level intelligence will ever be achieved? And secondly, whether AI poses any dangers to society. In 2007, it was roughly evenly split. Half the people said AI would never be achieved, half of them said it would. And the question about whether AI poses a danger to society, people treated that as a joke. You know, they laughed about it. Today, we can have a show of hands, but it seems like probably, well, let's do it. Yeah, how many of you think that human-level AI will be achieved one day? How many think it will never be achieved? A few people. Okay, why do you think it'll never be achieved? You think it's technically impossible, or you think people aren't using the right methods? Sorry? Technical problems. Okay. So there's still a few people who think it won't be achieved, but I have to, you know, you guys are in the minority now. I don't know. Well, the last point I wanted to make in this introductory part is about, so some tasks that were thought to be easy turned out to be hard and vice versa. So who can tell me what movie this image comes from? 2001. 2001 A Space Odyssey, that's right. Now, what's happening here is Dave is playing against the computer, and the computer's beating him at chess. Now, Stanley Kubrick was a big fan of chess. I think this game here is actually taken from some historical game between two Polish grandmasters in the 1930s. When they were making the film, they considered having some other game that was more like kind of Tetris or Breakout or something, but they decided they had to go with chess because people are familiar with chess and they know that it's hard. And it's hard for us to put ourselves back into the mindset of 1969. A human being beaten by a computer at chess would have been very shocking to the people of 1969. To us, it would be shocking if it would be shocking to us if a human beat a computer at chess. But to them, it was the other way around. But notice what's happening. There's several scenes in the film where Hal is doing analyzing computer vision and figuring out what's going on, and it's even able to lip read when people are whispering, and there's one scene where it even lip reads from the side, someone's side on, and Hal can tell what he's saying, which is hard even for humans. So in 1969, people kind of didn't realize how hard these vision problems are. So you get this weird kind of, I think, Pamela McCorduck mostly wrote about part of this in her book, Machines Who Think, that, once a task has been achieved by computers, we don't think of it as intelligence anymore. So some people define artificial intelligence as the set of tasks which can be done by humans but can't yet be done by computers. So the goalposts are always receding. But I guess the point I'm making here is that there are some cases where it's actually coming back the other way. There are things, computer vision initially wasn't really thought of as part of artificial intelligence until people realized that it's actually hard, and now it is. Okay, this is something you can look at for the tutorials, a list of different tasks and to what extent they've been achieved. And so it's got a long history in diverse areas of science, philosophy and literature. Debates continue about the definition of intelligence, and significant progress has been made, but many challenges remain. Okay, so at this point, I think we'll take a 10-minute break at this point. When we come back, we'll talk a little bit about prologue, and then if we have time, we'll come back to some of these other questions. Yeah.
The CSC accounts.
Yeah.
I can't figure out how to sort of, find. We're supposed to get like an email link saying, we invite you to take this. I don't even know, I've been trying to Google it and it wasn't really obvious. It was weird.
That's a good question. So, you're a postgrad.
Postgrad grad.
Oh, but you're not taking 902.1, I assume. You're not taking
Oh,
you are?
Yeah.
Oh, the Python course?
Yeah.
Oh, did they tell you anything about how to log in, or are they're using some other system?
They use the thing through Ed.
Oh, it's all through Ed, is it?
Yeah.
Okay.
I think it is.
I'll look into this. I think the answer is just that you go to the lab and you log in with your Z
Okay.
ID, and then set it up for you. But I think it's easiest if you physically go to the lab rather than phone.
Okay, so it's a CSC account for like lab work then, is it, or is it something else?
Well, the assignment, you'll be sending the assignments to your system.
Okay, so it's kind of an issue. Okay, well, cool, I guess.
I think I might use my laptop during the tutorial, and I just want to know how to set up the connect in my laptop with
Yes.
stuff.
Look, normally, I don't know why this.
Do I need a new interface because
What kind of laptop do you have?
it only has the lightning interface, and I guess I might.
Ah, yes. Do you have an adapter? I normally have one, but somehow I didn't bring it today.
Okay, maybe I take a photo.
Yeah.
Yeah. And after
I
I
can see whether you don't have a HDMI. Oh,
Yeah.
no, that's it. Yeah, okay. Yeah, you probably need
a
a
new adapter, and after I get adapter, what else do I need to the button?
Well, assuming it's the same interface in the rooms, you click more inputs, and then you click probably VGA laptop. But somehow.
So
Well, students. It's just some rooms I found HDMI works, but not VGA. But
okay,
VGA
I'll
might
go
be-
with more inputs and
probably VGA laptop.
VGA laptop.
Try to go to the room beforehand just
Yeah.
to check it out.
Thank you.
I just had a question that like the Prolog programming language.
Yeah,
So is it like used for like completely for building out intelligent agents, or is it like for like solving problems like AI problems?
Both, really. Yeah,
So like
yeah.
also like in terms of research and like that, like where does it research?
It was originally mainly used for searching. Constraint satisfaction, path search, game search. But it is also used for agent architectures. Yeah, so there's this kind of extension called GoLog, which is often used for cognitive robotics and stuff.
So like for example, like if someone's trying to build out a game, is it like combined with other programming languages? So is it like simply you just start off with Prolog to build out the agents?
It can be combined with other languages, and there's other. There are related languages like Mercury and Scheme and Haskell, which are often integrated with C. So sometimes you get these, the C is used for the kind of inner loop fast stuff. And with Prolog, sometimes Prolog is interfaced with other languages, but we won't be sort of getting into that in this course.
Thank you. the
Ah,
tablet.
yes.
I'm unable to find the lecture slides. Are they uploaded or?
Yes, the lecture slides are right. So
Clipping this.
yeah, every icon that looks like that.
Like 6.
Yeah.
So the lab session is what you're talking about, right? So say if we have some doubt or something, can we just like come in at any time, or are we expected to be there for the whole?
You can come in at any of these times. It's up to
Say
you.
it's like 4 to 8
Yeah.
at the time. So are we like supposed to be there from 4 to 8?
No, any time in between.
That should be fine.
Exactly.
The general question, what you're talking about intelligence,
Yeah.
like I would say it is human. What we talk about logic and reasoning, all that can be definitely achieved by computers. But
Yeah.
the part about subconscious and something beyond that, which so that I feel is like maybe unachievable. So
Emotions. Yeah.
no, not emotion, something beyond that, like something beyond what you call as
Intuition.
yeah, something like that. But the other part definitely could be, even emotions can be like simulated by AI. So it's like partly on both the sides.
So there's some part of human intelligence that goes beyond kind of logic.
Yeah.
Yeah. Good. Makes sense.
So I'm not in both the, like you said, there are one set of people who think AI cannot be completely achieved. So another set of people who are like, can be achieved. I'm like, some parts of AI can be like, some part of intelligence can be simulated, but some part.
I see.
Will the lecture videos be uploaded?
Yes, the
Is it echo?
echo recorders will be uploaded.
Because some of the other subjects, they're not at all uploading for this week. So I was like, will it happen if I miss the class or something?
I think it should happen. I mean, a lot of the,
Because there are some web stream students too.
yes.
So if at all I miss the class, it will be
I hope maybe what you described might be some technical difficulty or something, but I hope that it will happen. I mean, we just some hours later, sometimes late in the night, I get an email saying, because it has to be processed and
Right.
stuff. So probably around midnight, I usually get an email saying that it's ready. So I hope. Occasionally there is a technical problem, but hopefully that won't happen.
So another thing is, I've actually booked for a Wednesday tutorial for now.
Yeah.
Is it possible to change later on?
Yes, look, if you can
I don't
you
know.
can change officially, it's better, but it's okay if you just want to attend a different tutorial because the role isn't taken. It's okay if you just go to another one.
Oh. And the other thing is AI subject necessary for learning machine learning and science?
It's not a prerequisite.
Not officially, it's not a prerequisite to understand machine learning. Is it
help you somewhat. There are a lot of people. In the past, machine learning was taught in term 1, and there were quite a few people who took machine learning without AI, so it is possible. We kind of focus on different things.
Would you ever give me this after the lecture? I just want to talk to you because I work full time, so I'm not sure if I'm attending lectures and just wondering if that's going to be a concern in terms of missing stuff that may not. I'm worried that 360 doesn't work well, you know what I mean? Or if you mention things in the lecture, it's good to have these discussions, but I just don't think I'm going to be able to get away with it.
Yeah, hopefully 360 should work. Again, we very rarely have problems on it. I mean, a lot of the material is already with those.
Yeah, I noticed that. I've gone through quite a bit already, but I haven't, I just, well, if I can get everything I need from that, I think it will work for the prologue and stuff like that. I mean, you're on email, so if I get stuck with anything like that, then you can get I just don't think I'm going to be able to come to this time slot. I'm just lucky enough to things at the moment, so I've got away with it, but it's always a joke.
We used to have it in the evening, but the vast majority of people wanted to have it.
Well, I understand that most of the students are on campus, so yeah. All right, cool.
Should be okay.
Yeah? Okay, thanks.
I don't know what to think about. Some of them have captured in addition to, I think the machine learning captured at 600, but it's pretty high. There is talk of it being offered in 700 as well. I don't know. That's actually quite light.
No, I have heard that. Yeah, I was more interested in that. At this point, anyway, I think it might be I think knowledge representation is like something. All right. And I think someone said that if enough people fill out saying they might do
Okay. So now I'm going to talk about Prolog. Now, first of all, just a little bit about kind of computing and home computing. So those of you, if you're a postgrad and this is your first session here at UNSW, you should set yourself up an account on the CSE machines. I think you do that by just going to the lab and typing in your Z ID and your Z password, and then follow the instructions. So it's good to do that because then you can run when it comes to the assignments, you can submit from the command line, and you can run your assignments using the lab machines and make sure that it all works correctly. So I know it is possible to submit assignments through the web form these days, but it definitely should have a CSE account. Okay, so try to do that if you haven't done it already. Now, just a little bit about how to remotely access. So, how many of you use a Mac? Okay, how many of you use a Windows, some kind of Windows? Yeah. Okay, so let's talk about Windows first. So the easiest way to log in is just using PuTTY. So you can download PuTTY onto your machine and then run it. So this is the way PuTTY works. When it says host, you type in login.cse.unsw.edu.au. I like to change the font size so that you can see it here on the big screen. We may need to change the colors as well, but let's just try this. That's not too bad. Maybe I need even a slightly bigger font here. Hang on. It's possible to save the address so you don't have to type it in each time. All right, let's try 16 point. I think I use system color. No, that's no good. One more time. All right, so then I type in my CSE username, which for you guys is almost certainly the same as your ZID, and then the password. Now, when you type in the password, nothing appears on the screen when you're typing in your password. If you're expecting to see little dots appear on the screen, it's not going to happen. But it is receiving your password, and then you can log in. And then it's Unix, and I have a directory structure here. So those of you unfamiliar with Unix, it's probably a good idea to try to get yourself a bit familiar with some of the Unix commands. If you're taking this 9021 course, you'll probably learn a bit about that there. Okay, now Prolog. So if you log into a lab machine, if I just type Prolog, then SWI Prolog will come up. Now, if you're working on your own laptop, you have to sort of download it yourself. So now I'm going to go to this Open Learning page. So if you click on Learning Activities, you can go to Prolog Introduction. Well, sorry, what you should do is click on Lab Exercises. And at the top here, there's a button here where you can download SWI Prolog, and you can choose your operating system and so on. On the Mac, it may be possible to do it through a package manager if you prefer that. So I installed it on my Mac by just doing using Mac ports. I just did port install SWI Prolog. That should work. And if you're using Linux, maybe you can use apt-get or something like that. So there's a few different possibilities, but one way or another, you should try to get SWI Prolog running on your own machine. Now, I got some references here. So this is a link to the the reference book I mentioned, this Bratko book. These are the course notes that we're going to be that I'm going to be going through in these lectures. And if you look at those little videos, it's going through these course notes. Now, this Prolog dictionary is a very valuable resource. This was put together over a number of years by a former colleague of mine who's now retired, Bill Wilson. But he just collected, a lot of people asked questions about Prolog, and he built up this Prolog dictionary. So if you've got any questions about Prolog, a lot of it can be found here. So that's very useful. This is the reference manual to SWI Prolog if you need it. And finally, this code q.si is a useful website. You have to create an account here, but it's free. This is just a sort of extra resource to help you. If you need a bit of extra help, some extra exercises for Prolog, you can get them here. A colleague of mine called Tatiana Zrimek, who actually taught this course over the summer, she helped to put this together. She normally is affiliated with the University of Ljubljana in Slovenia, where Ivan Bratko, the author of the textbook, is located, and they kind of worked on this together. Originally, it was all written in Slovenian, but she tells me she's translated most of the important stuff into English now, so you shouldn't have any problem with that. So that's just an additional resource. All right, so once you get set up, and then if you're on the Mac, instead of Prolog, you type SWIPL, SWIPL. So, and there may be a couple of other things you need to do to set things up properly. I think that's covered in these notes. Okay, so now let's look at this. Introduction. Okay, so Prolog was invented in the early 70s by Alain Kolmauer and Robert Kowalski. I always have trouble pronouncing this guy's name. Sorry. Now, it's so it's I'm going to draw your. So again, I'm not going to go through all the details. I want you to look through the videos to see the details. But I'm just going to summarize it, and I'm going to particularly draw your attention to the differences between Prolog and an imperative language. So I've got this. So what happens with Prolog? So with an imperative language, you kind of give it a list of instructions, and it executes those instructions one by one. What happens with Prolog is you enter certain facts, and then you have certain rules, and then you ask certain questions. So it's a little bit like a database, in fact. But you have the facts, and you have the rules, and then you put in queries, and it tries to see whether it can match the queries based on the facts and the rules. So in this example here, we've got, there's just these examples from these notes. So you imagine that you've got facts that say which lecturer is teaching a particular course and which students are studying which course. And so this is telling, so the facts are written like this, lectures, bracket, Turing, comma, 9020, full stop. That tells us that Turing is lecturing the course 9020, and Minsky is lecturing 9414, and so on. And Jill is studying 9314 and 9414. So this is a set of facts. Now, if I type Prolog -s and then the name of this file, it'll actually load in those facts. and then I can query the database. So I can say, is it true that Jill studies 9414? And it says, yes, that's true. Is it true that Jill studies 9314? Yes, that's true. Now, if I say, is it true that she studies 9310, it comes back as false, because that's not one of the facts that's in the database. Okay. Now, notice what happened here. This one immediately came back with false. This one, this one came back with true. Now, sometimes what happens is it comes back with true but doesn't give you a full stop, and then I have to press either return or semicolon. So I'll say a little bit more about that in a minute. Okay. So that's testing facts. Now, we can also ask, well, it gets more interesting if we put in a variable. So if I want to ask what is Jill studying, I can say studies Jill, course, and it comes back with 9314. Now, let's have a look at this. So Jill's studying two things. Jack is only studying one course. Right, so first the syntax. Now, course is a variable. It knows it's a variable because it has a capital letter. So anything with a capital letter is treated as a variable. So I could just write C, or I could write X. Anything like that is a variable. But if I write something without a capital, it says false because it's looking for something explicitly called course. So things beginning with a lowercase letter are actual items, and things with a capital letter are variables. Now, notice what happened when I asked about Jill. It comes back and it says course is 9314, but it hasn't given me my prompt back. Now, the reason for this is that there could be multiple answers, right? So when it said that Jack was studying 9311, that's the only answer. Jack is studying 9311 and nothing else. Now, here it's telling us, yes, Jill is studying 9314, but she might be studying other courses as well. So here we have two options. We can either just hit return, because we could think, well, I only want one answer, I don't need every answer. Or if you want to look at other answers, you can hit a semicolon. Semicolon means or, and then it'll go and look to see if she's studying something else, and it comes back and says 9414. Okay, so that's that behavior there. Now, if we go back to what happened here, this is a bit sort of funny because there's no variables here. I've just said, I've just asked whether Jill's studying 9314, but what it's actually doing here is seeing whether it can prove that in different ways. So it says, well, I found one way to prove it, but I can go and look for another way, but then when it goes and looks, it can't find it. So you do get this sort of funny behavior. When it does this, it doesn't necessarily mean that there are more answers. It just means that there might be more answers. But then when it looks, maybe there aren't any more answers. So you kind of get used to this functionality. All right. So that's the first thing we do, is just a single variable. But where it gets more interesting is if we combine two different facts to make a new fact. If we just look at this list of facts here, I might be interested to ask the question, well, which students is Turing teaching. So if you can read this, how would you find out, how would you answer the question, well, which students is Turing teaching? Well, that's a kind of indirect question, because you'd have to figure out, first of all, which courses Turing is teaching, and then which students are taking those courses. So if I ask, if I'm looking for a student who Turing is teaching, I have to look for some course such that Turing is teaching that course and the student is studying that course. So the way that works is as follows. I say teaching Turing course, comma, so the comma is and, semicolon is or, comma is and I say studies student. So here I've got one variable linking two different rules, sorry, teachers. Lectures, sorry. It's not as smart as Watson. It has to be exactly. Actually, you've got to keep this in mind when you're doing your assignment. Make sure there's no spelling error or anything like that, otherwise it won't be understood. Okay, so here it says, okay, Turing is teaching 9020 and Fred is studying 9020. Now, and that's the only answer, right? Now, what about COD? COD is teaching a couple of different courses. So it's come back and told us, okay, COD is teaching 9311 and Jack is studying that. If I press semicolon, it says, okay, he's also teaching 9314 and Jill is taking it, and Henry. So there are three different solutions to this query, right? And so this is what Prolog kind of does, is you type in this query and it tries to look for values of those variables, which makes this query true. And if the same variable appears twice in one query, then it has to have the same value. Okay, and this is done by a process. It does this searching by a process of backtracking. This graphic here is particularly useful. It shows what happens when you type in this query. So if we try to sort of anthropomorphize this, it's saying, okay, first I want to look for a particular value of course, and one possibility, so it looks for a fact that says lectures COD something, and it says, okay, that could be 9311, and then it searches and says, well, if the course is 9311, then I want to look for a fact that says studies someone 9311, and it finds Jack. And then it looks, if there's any other students studying 9311, it doesn't find any, so then it goes back and says, okay, maybe I'll look for another course that COD is teaching, and it finds 9314, and it finds two values of that. So this is like a search tree. We'll be talking, when we get to week 3, when we get to modules 3 and 4, we'll be talking a lot more about search trees. Some of you have seen them before in the data structures course, but this is like what we call backtracking search, okay? So, and then the other thing, it's not debugging with Prolog is a little bit, it's not as clean as in some languages, but if I say trace and then I type that query again, you can actually kind of see, oops. Sorry, let's start this again. You can actually see, you get used to this after a while, this trace is actually telling you how this process is working. So it's saying, okay, I want to look for some variable such that there's a fact lectures called something, and it gives that variable this kind of funny internal name, underscore G3516, and it identifies 9311, and then it looks for studies underscore 9318 and 93. So, there's these funny kind of internal variables, and then if I keep hitting semicolon, then you can see it backtracking and trying a different value. So I encourage you to spend some time looking through this trace and looking at this tree and trying to understand the relationship between them. Okay. Are there any questions about this? Yeah? Good question. So if Jack had been if Jack had been studying both of these courses, he would appear twice because well, now that you mention it, yeah, let's try that. So it would appear twice because it's a different combination. Because I asked for both the course and the student, Jack and 9314, Jack and 9413 is two different answers, right? But don't take my word for it. Let's just... I'm just curious. Let's just add that and see what happens. Okay. Let's say studies Jack. Nine 314. Let's see. Yes, Jack appeared twice. Now, since you asked, perhaps I should mention, if I put an underscore here, that means, well, let's see what happens with this. Okay, course, yeah, okay. Okay, same. So I just want to try something here. Okay. All right, don't worry about that. Okay, so it came back with two different combinations. Yeah. Now, okay, but it's tedious if we have to type this in every time. What we really want is a rule that tells us when someone is teaching someone else. So the way we do that is as follows. So let me just copy this here so that we can, oops. Something a bit weird happened here, but normally to exit Prolog we do Control D. Okay, so we've got the facts here. Now what I'm going to add at the bottom is a rule, and the rule looks like this. I'm going to define what it means to have teachers, teacher, student, and then This thing here, it means if. So this defines the rule. So I say lectures, teacher, course, and studies, student, course. Okay, so that defines the rule. Teachers, teacher, student is true if lectures, teachers, course, and studies, student, course. So that's been added to the bottom of that file. So if we launch Prolog again, now if I ask teachers cod student, it come. Yes, I made a spelling mistake. Student equals Jack, Jill, Henry, Jack. Sorry, this is the point I was trying to make earlier. Yeah, here I've suppressed, because the course appears in the rule, but not in the query. So when it comes back, it doesn't tell me the course, it just tells me the variable that I specified in the query. So it actually tells me Jack twice, because cod is teaching Jack in two different ways. Yeah, so this sort of looks like it's the same information twice, but what it's saying is I can prove this in two. This is the same fact, but I can prove it in two different ways. Yeah. There are ways to exclude multiple answers. Yeah, yeah. If you look in the Prolog dictionary, you can see this. Yeah. Good. And this is well, just another. You can look through this yourself, but this is another example of how something can be proved in different ways. You know, I can explicitly tell you that Fido is a bad dog, and then I can have a rule that says that a dog is a bad dog if that dog bites a person, and then I can tell you that Fido bit the postman, Fido bites the postman, and the postman is a person, and Fido is a dog. And then if I ask, is Fido a bad dog? It says true twice because it can prove it in two different ways. It's just there directly as a fact, or it can prove it using this convoluted rule. Okay. All right. So again, you know, you can look in the videos for the details, but I'm going to move on now to a slightly more elaborate example, which is this library database. So now and then there are other examples. If you work through the examples, if you work through the exercises, there's a bit more of a traditional example which is to do with family relationships. You know, if X is the parent of Y, X is the mother of Y, if X is the parent of Y and X is female, all this kind of stuff. You can explore that for yourself. So this is a different example that's showing a library database. So, you know, we imagine that these are books in a library. It's a little bit convoluted, but the facts are given in this format. So I say that there's a book with a certain catalogue number, a certain title, and a certain author. And then there's a member of the library with a member. So this is, this is telling me book number 1 is called Prolog Programming for Artificial Intelligence, and the author is Ivan Bratko. You see, so this tells you how strings are handled in Prolog. A string is actually a list of characters. We'll talk more about lists next week, or you can go through that yourself, and it's given with a single quote. And then I've just decided that the author, I've decided that the author is going to be given in this format: author, open brackets, Brat, and then the last name and the first name. Okay, so there's information about books, there's information about members of the library and their address, and there's information about who borrowed what book. So if I want to run Prolog again using this library database, okay, so let's just look at how we can probe this. So I can say, okay, I want to know what's book number 1 in this database, what's its title and what's its author. And it comes back and says, Prolog Programming for Artificial Intelligence by Bratko. Now, but I can probe this any way I want. So I could say, well, I'm thinking of a book. I don't know what the number of that book is, and I'm not sure what the title is, but I know that the author is Ivan something. Right, so I just specify whatever information I have, and it comes back and tells me the rest of the information. You know. So it's really just sort of fancy pattern matching. You know, you put in what you know and it tries to find out the rest. And then if I want to do a kind of query that combines different things, I would, you know, what does it mean that someone's borrowed a book? Well, if they've if a person with a certain name has borrowed a book with a certain title and a certain catalogue number, it means that there must be a member of the library with a certain membership number, and they must have this as their family name, and then there's got to be a book with a certain title and a certain catalogue number, and there has to be a record of a loan of something with that catalogue number by that member number. So this is sort of, it's a bit like those of you who studied databases, this is a little bit like a relational database, but we can do more sophisticated things with this. So this is something you can have a play around with if you like. Now these underscores, the underscore means I don't care, I don't want you to tell me what that value is. It's just got to have some value, right? So if I put underscores here, I'm not sure what happens if I put underscores here, whether it tells me or not. Is there a book in the library written by a person called Ivan? It just says true. So it only tells me what I want to know. I want to know the title of the book by Ivan, but I don't want to know the book number or the last name. Yeah, so the underscores don't care. It just says, you know, don't bother to tell me what that is. But sometimes we do need to we had to specify catalogue number because we need the same catalogue number here and here. The catalogue number of the book must be the same as the catalogue number in the loan record, and the member number of the membership number of the member must be the same as the membership number in the loan record. So these things have to be in there because they have to match, but the other things don't. All right. Now let's talk about arithmetic. So the way Prolog does arithmetic is we have to get used to, so we can just sort of try by typing things in. Now, if I type 2 plus 3 equals 5, do you think that would be true or false? It's actually false. And the reason is that this 2 plus 3, Prolog treats that as a structured object. If I did 5 equals 2 plus 3, I get the same result. So if this equals, in Prolog, things are not equal unless they're actually identical. So this 2 plus 3 is an arithmetic expression, and it's different from 5. Now, if I want to know, if I want it to be evaluated, then I have this thing called is. So 5 is 2 plus 3, that's true. So the word is means that I evaluate the thing on the right-hand side and check that that's equal to the thing on the left-hand side. There's a little table here that lists these different, so there's different types of equality in Prolog. Now, and this is a one-way thing. It always evaluates the right-hand side and checks if it's equal to the left-hand side. So if I say 2 plus 3 is 5, that's no good. If I say x is 2 plus 3, that's okay. It evaluates 2 plus 3 and tells me that the answer is 5. If I say 5 is 2 plus x, logically that makes sense, but Prolog refuses to calculate this. So in order to use is, by the time it gets to the is, it must know the value of these things on the right-hand side. So if I say x is x is 7 minus 4, and y is 2 plus x, oops, then it's okay, because first it figures out that x is 7 minus 4, which is 3, and then by the time it gets here, it knows that x is equal to 3, so it knows that y is equal to 5. So by the time it gets to the is, it has to know everything that appears here on the right-hand side. Now, if I want to know whether 2 plus 3 is the same as, say, 9 minus 4, then I have a different type of equals, which is written like this. So this expression here evaluates both the left and the right-hand side and checks that they're equal. Okay, but again, I may have trouble with variables. It's not going to do this if it's not going to look for a value of x that makes this true. It'll only check, if it knows what x is, then it'll check to see whether this is true. Okay, so there's a little bit of subtlety about this arithmetic. Now let's look at how to put this into a rule. Okay, so first of all, we've got this example about later. So if someone's borrowed a library book, we may want to know whether it's overdue or not. So in order to check that out, we have to have a way of representing dates, and we have to have a way of checking whether one date is later than another date. And this is how it's done here. So dates, we simply choose that dates are going to be represented in the form date bracket 2015, the year followed by the month followed by the day. So a lot of this is, sometimes we just call this syntactic glue, because I could have instead of member, I could have called this lib member. Instead of name, could have called this something else. I could have decided to put the last name, the first name before the last name. but I've just chosen these particular names and this particular order, right? And when I do a query, it'll try to match the names and the order that's in the facts. So what does it mean that if I want to have a predicate later that tells me, whether one date is later than another date? So, I mean, let's think about this. Well, let's run this first and then think about how the code is written. So later, okay, so today is 2019 2/22. Okay, that's false. But if I swap these around, it's true that this date is later than that date. Okay, so let's think of another example. Let's say this is January 22. So is February 23 later than January 22? Is that true? Or false? What about this one? So if I generally tell you, if I give you a year, if I give you year 1, month 1 and day 1, and then I give you year 2, month 2 and day 2, can someone, Prolog will refuse to do this because I didn't tell it enough variables, but can someone tell me a rule for how do you know if one date is later than another date? Or perhaps 3 separate rules based on these 3 examples. So how did I know that the 23rd of February is later than the 22nd of February? Sorry? Yep. The other two are the same, exactly, that's right. So if the year and the month are the same, then the day has to be bigger, right? So that's one situation in which it's later. The same year, the same month, and a bigger day, okay? Yes? Okay, I'll come back. All right, so the question was, look, let me come back to your question in a minute. So that's one rule. Now, what's another situation in which a date is later? Have a look at this example. What's happening here? Yeah? Right. The year is the same. If the year is the same and the month is bigger, then it's later, right? It doesn't matter what the day is. And what's the third rule? What's happening in this case? If the year is bigger, then it's later. It doesn't matter what the month and the day are, right? So this is the way this is written in Prolog. It's these 3 rules. So later, so this is the one, we write this as 3 separate rules. If the year and the month are the same, if you've got something of the form year, month, day 1, and then you've got the same year and the same month and day 2, then this is later if day 1 is bigger than day 2. If you've got a year here and the same year here, and you've got month 1 and month 2, then it's later if month 1 is bigger than month 2. And if year 1 is bigger than year 2, it doesn't matter what the month and the day are. Okay, so I think you can see the logic of this, but I want to make 2 points here about Prolog style. Okay, so let me just edit this. So the first point is this, that if 2 things have to be the same, sorry about the colours, but hopefully you can still read that. Oh. Let me not try to type this, let me just explain it in words. So, the first point is that if 2 things have to be the same, it's better to use the same variable. So, some people, when they start writing Prolog, they would write y1 here and y2 here, and then they would say y1 equals y2. So that works, but it's better style. If 2 things really have to be equal, it's better to just use the same variable. It simplifies the code. Instead of saying y1 equals y2 and m1 equals m2, better to just use the same variable. That's the first point. The second point is, again, if you're used to Python or C or Java, there's a temptation to, if you think about how we'd write this in those languages, we would say, if year 1 equals year 2, then do this. Else, if month 1 equals month 2, then do this. And we would write the thing as a series of if and else statements. It's possible to do that people feel a natural tendency to do that in Prolog, but it's bad style. In Prolog, it's much better to split it up into 3 short rules rather than having one complicated rule with lots of ands and ors and elses, right? So this is the clean way of doing it. You specify one rule. If that rule fails, the system will automatically try to apply the next rule, and if that fails, it'll try to apply the next rule. So this is a simple example, but it's a good example to help you learn good style. Okay, any questions about this? I don't. Okay, there are some built-in predicates in Prolog. So there's a built-in list predicate, but I think in the exercises we ask you to create your own just so that you have the experience of having to write your own predicates. So a lot of these exercises I'm showing, some of the exercises I'm showing you are actually taking built-in predicates and saying, well, if it didn't exist, how would you implement it? As far as dates are concerned, I'm not sure whether there's a standard convention for representing dates in Prolog, but this is just showing you how you could define it for yourself. Yeah. And then this last bit of the code is saying what the due date is. So if I borrow a book today, let's say that every book is borrowed for 1 month. If I borrow a book today, if I borrow a book on a certain date, what's the date on which the book is due, right? And this is where we need to use this is, right? So this due date, I specify Sorry, let me just run this to make sure. So due date. Okay, so let's say I borrow a book today, 2019-222. When will it be due? And it comes back and says, okay, you borrowed it on the 22nd of February, it'll be due on the 22nd of March, right? So right, so let's think about what's happening here. It just took the month and added 1 to it. Now, what would happen if you borrowed a book? So in most cases, we add 1 to it, but let's say you had a book that was borrowed on the 22nd of December 2018, the month wouldn't become 13. The month was 12, it wouldn't become month 13, right? So we need another rule which says that if the month is 12, then the month should become 1 and the year should become 1 bigger, right? So it's the 22nd of January 2019. So this is actually the rule. So we need these two rules to tell us the due date. So the first rule says that if the month is less than 12, then the new month is month 1 plus 1. The second rule says that the year 2 is year 1 plus 1. Now again, there's a couple of important points to make here. So first of all, if you're if you're used to Python or Java, you would write something like x equals x plus 1. You know, there's a temptation to say month equals month plus 1. But in Prolog, and because in an imperative language, when we say month equals month plus 1, what that means is that the old value of month was something, and I add 1 to it, and then the new value is something else. So it actually dynamically changes. In Python, in Prolog, we're not allowed to do that. You can never say month 1 equals month 1 plus 1. That would always be false. So instead, we use two different variables. We have month 1, and then we have month 2, and month 2 is month 1 plus 1, right? So we often have to introduce a new variable like this. Now, and then we use this is. So if month 1 was 1, then this 1 gets added and then this becomes 2, right? So we have to use is here, not the equals. And because we're using is, it forces it, unfortunately, to be a one-way evaluation. So I can't do the query in the other direction. If I asked, well, a book is due today, on what date did I borrow it? It refuses because it says that it's not sufficiently instantiated. So if I tell it the value of year 1, it'll evaluate this and come back with a value for year 2. But if I tell it year 2 and ask it to go look for year 1, it refuses. So this is like a one-way street. The is can only work in one direction and not the other. Okay, so that's mainly it. There is something, just finally, this rule doesn't quite cover all cases, because let's suppose I borrowed a book on the 31st of January. Oh, sorry, later. If I borrowed a book on the 31st of January, when would it be due? 31st of February. What's the 31st of February? So if you really wanted to make this robust, you'd have to put in special cases for how long the month is and everything. But we don't want to get into all that detail. Okay. So, like I say, this is just an overview of Prolog. Next week we'll go and talk about structures and that sort of thing, but in the meantime, please have a look at those videos, please work through those examples, and I hope this will become a bit more, make a bit more sense. So I've got one more topic I want to get to because we've still got half an hour, but does anyone have any questions at this stage about Prolog? Good. Okay. So yeah. Since we've got some time, I want to just make a little bit of a start on the next module. So this gives us, first of all, gives us a little bit of an overview of the next few weeks and kind of puts the whole thing into a general framework. So these are some examples of the kind of AI tasks that we're going to be looking at in the next few weeks of the course. So we're going to be looking at first of all, at the Wumpus world, and then at some path planning tasks. Well, we're going to look at the Wumpus world, and then we're going to be looking at RoboCup soccer. Then we're going to look at some path planning tasks, like how to plan a path through a graph or a robot, motion planning for a robot. We're going to be looking at how to solve puzzles like the 8 puzzle or Rubik's Cube. Then we're going to be looking at game playing, and then constraint satisfaction problems like Sudoku, and so a variety of different tasks. And what we want to have is a kind of unified model that allows us to specify different tasks. And the one from the textbook well, in the most general case, we can think of an agent interacting with its environment, and it takes percepts from the environment and then does actions on the environment. And so we can think of the agent as a sort of function that takes a sequence of percepts and produces an action. And in the textbook, they have this acronym PEAS, which stands for Performance, Measure, Environment, Actuators, and Sensors. So if you specify a task, you specify the environment in which the agent is operating, the sensors that the agent gets information from the environment, the actuators it uses on the environment, and how do you tell whether it's doing a good job or not. So these are just a couple of examples. If you're playing chess, the environment is like the board and the pieces. The sensors will tell you which piece is on which square. The actuators enable you to move a piece to a new square. And the performance measure, well, at the end of the game, if you get a win, it's +1. If you lose, it's 0. And if it's a draw, you get a half. You know, so that's one example. Another example is an automated taxi. Well, this is just an interesting exercise. If you think about a task, you can think about, when you think about the environment, it helps you to understand what challenges the agent has to face. So if you want to write an autonomous driving agent, what sort of things does it have to deal with? City streets, freeways, traffic, pedestrians, weather, and of course, there was that terrible accident last year where a pedestrian got run down by an autonomous car. The sensors might be well, we'll look in more detail next week, but the sensors might include a video camera, accelerometers telling you how fast you're going, GPS and various other things, and the actuators would be the steering wheel, the accelerator, the brake, the horn, and so on. And what about the performance measure? If you're building an automated taxi, how do you measure its performance? Well, the most important thing is safety, but also it should reach the destination, maximize the profits, obey laws, passenger comfort, and so on. Okay. Now, I just want to introduce you to this Wumpus World environment because we're going to be using this. Let me see if I have it here. We're going to be coming back to this Wumpus World environment repeatedly throughout the course. And the way it works is as follows. This is based on these kind of text-based adventure games from the 1970s. So you start in a particular square, and somewhere in this environment is a bar of gold, and the objective is to move around, find the bar of gold, and go back to the entrance. So we're in a kind of cave, we've entered the cave, we've got to go find the gold and come back, but there are certain hazards along the way. So some squares may have a pit, and if you go where there's a pit, you're going to fall down and die. And some squares have one square has a wumpus, and if you go where the wumpus is, you're going to get eaten. Now, if you go to a place next to where there's a pit, you're going to detect a breeze. So that's a warning about the pit. And if you go near where the wumpus is, you're going to detect a stench. And if you go to where the gold is, you'll see a glitter, but you have to be absolutely there. And those are the things we can detect. So if we treat this as if we try to come up with a P's description of this, the sensors we can detect are breeze, glitter, or stench. The environment, well, this is a description of the environment. The actuators, the actions we can choose are left, right, forward, grab, or shoot. So we have an arrow. In some situations, we may be forced to kill the wumpus. So we have a bow and we have one arrow, and we can shoot the arrow, and if we shoot it in the direction of the wumpus, it will die. And then the performance measure, well, it's mainly based on whether we successfully, if we die, we lose 1,000 points. If we manage to get back to the entrance with the gold, we're going to win 1,000 points. And we lose some points for shooting the arrow. So we shouldn't kill the wumpus unless we have to. If we shoot the arrow, we lose 10 points, and we lose 1 point for every step that we take. So there's a little bit of an advantage to solving the thing quicker. Okay. So I've hacked up a sort of Java version of this. These graphics are a bit hokey, but what this is saying is we haven't detected any breeze or anything. But if we move forward, we can just keep moving forward. Okay, so we've detected a breeze in this. We've been through these squares and we've detected a breeze here. So what does that breeze tell us? There's a pit. Where's the pit? Yeah. This tells us there's a pit in a neighbouring square. We know it's not that square because we just came from there, so it must be here. So we don't want to go into that square because of the pit. Okay. So what should we do instead? Let's go here. So we see the glitter, so we do G to grab the gold. Right, forward, left, forward. Okay, that was a relatively easy one. Now let's try again. Now, this is Russian roulette. Okay, we've detected a breeze. That means there's a pit in one of the neighbouring squares, but we don't know which one. So we could, I guess, just quit the game. But if we're feeling brave, we can just randomly move into one of the squares and we've got a 50% chance of dying. So let's be bold. Okay. We chose poorly. Let's just try a couple more. Okay, so there's a breeze there. Right. Now, this gets into probabilistic reasoning, which we'll talk about later in the course. Now, most likely the breeze, because there's a breeze here and here, it's most likely that the pit is here because that would cause a breeze in both places. But it is possible there could be a pit here and a pit here. So it is dangerous to go into this square, but we're going to risk it anyway. And what do you recommend? I think it might be, none of this is safe, but I think it might be slightly safer to go into this square. Ha ha! Okay. Right, so the Wumpus is nearby, but we don't have to worry about that. Okay, we won. Okay, let's try one more. All right, we'll try this again. We were lucky this time, relatively speaking. Oh, nasty. All right, I think you get the idea what's going on here. So there's a couple more examples on the video. So I just so this just introduces you to the piece, the idea of the piece description and the Wumpus world. Now, just one more thing I'd like to do before we leave, since we've got a couple more minutes. I would like to go back perhaps to this discussion about AI and the dangers of AI. Okay, well, first of all, let's talk about AI in literature. So what are some movies that you guys have seen? What are some sort of more recent movies that deal with AI that you think make an interesting point about AI? Sorry, which one? What? iRobot. Yeah. Who's seen iRobot? Right. Okay, so what would you say that iRobot tells us about AI? Well, There's the 3 laws of robotics, right? Okay. So this was an attempt to write some laws that would make it safe to work with robots. A robot may not injure a human being or through inaction allow a human being to come to harm. A robot must obey orders given by human beings except where such orders would conflict with the first law, and a robot must protect its own existence as long as that does not conflict with the first or second law. Now, I guess the point of that movie or the book is that even you define some laws like this, things may go wrong, right? And I think if you look at sort of robots that have been developed for battle situations in places like Afghanistan, you can see the effect of this. You know, like often you're in a situation where you want to be on good terms with the local warlord, but you're not sure whether you can really trust him, and he may have his own agenda, and he may be trying to gain territory from another warlord. And so really, especially once you get into battle situations, it's not easy to, whatever laws you come up with, they're going to have unintended consequences. Who was it who suggested iRobot? Is that a reasonable summary of this? Okay, let me just ask about, again, in the tutorials you can develop this more, but what do you think about the dangers of AI? Who thinks that there's a serious danger that the human race may get wiped out by killer robots? You do. Yeah, or you want to ask a question? Yeah? You think so? Right, so there are various risks involved, I guess. There's the risk that the robots might eventually just take over and not see any need for humans. But there's also, I don't know if I had a link to this kind of execution robot video, but yeah, that's the other problem, is humans, terrorist groups could reprogram robots to assassinate a particular person using a drone or something like that. So it might not be a simple case of the robots fighting against the humans. It could just be a general breakdown of law and order is another risk. Yeah? An arms race. The question was, do I consider it another arms race? Well, that's a good question. I mean, I think if we think about the old days of the so-called Cold War, it was mainly about governments racing against other governments, you know. But I think this may be worse in a way, because it's not just an issue of governments, it's also an issue of these kind of renegade groups, and it may not be very easy to negotiate with them the way the US and the Soviet Union used to negotiate. Yeah. Yeah. So the question was about the arms race. I mean, I'm sorry. I know. I know it's late. I just a couple more minutes here. The question about the arms race. I mean, putting aside the idea of killer robots, what do you think about the risk of AI technology just simply being concentrated on in very few hands? You know, a small number of private companies. Do you think that's a problem? Yes.
So would it be shown to be somewhat of a problem with Monsanto taking over and trying to control our food?
Uh-huh.
So that just goes to show that bigger companies with a lot of power don't exactly put huge interests in their policy.
Yeah, so the point...
But the interesting thing is they really keep kept in check by the general population.
Right.
But that don't go unchecked for long.
Okay, one last question. What about unemployment? Who thinks that... Some people think that the number of jobs is going to massively decrease. Other people think new jobs will be created. What do you think? Yeah? Shh. So the point that was made is that the financial benefits of technology should be distributed more widely than they currently are. That somehow technology, well, this is one view at least, is that technology by itself is not good or bad, but what's happening is that certain groups in society are using technology to create more and more wealth inequality. And if we keep going down that track, we may end up in a very dystopian future. Yeah? Right, so the point here was about the Industrial Revolution leading to communism and fascism. Yeah. I mean, that's right. So the Industrial Revolution, well, there are 2 points. So first of all, the Industrial Revolution, eventually new jobs did emerge out of the Industrial Revolution, but it took a long time. I think it took about 40 years. There was sort of 40 years of disruption in the middle where there was high unemployment. So if you come and tell someone, well, it's okay, everything will be nice 40 years from now, most people aren't going to be very happy to hear that. They worry about what will happen in between. But the other question is whether these jobs will ever exist at all, you know, because I guess there's a problem. Some people say it's different this time, that whatever new job is created, probably computers will learn to do that job better than humans as well. So, but it's interesting what you said about Marxism. So you think that Marx maybe is relevant again today? Yeah. Right. Right. So Thomas Piketty, I guess, has made this point, right? He called his book Capital in an obvious reference to Marx. Yeah. A final thing.
When computers first became popular and mainstream,
Yeah.
everybody thought we were going to automate the world and everybody would be able to live at the beach while the computers did all the mundane work.
Right.
And then out of that came a whole industry, which we're all sitting here as computer people because of this industry.
Right.
And then you have something like the internet, which could never even be conceived. So who knows what's going to be on the horizon?
Right. Okay. So the point here was that it was thought back in the 50s and 60s that one day we'd all have more leisure time because of automation, but it hasn't quite worked out that way. I guess you guys being here in this class, the good news is that you'll probably have jobs. You'll probably be the last people to lose your jobs. You'll have jobs later than anyone else. Well, I don't want to be negative, but to be honest with you, sometimes I worry about this. Sometimes I wonder that our grandchildren will look at people like us the same way we look at Nazis. They'll ask us, well, why didn't you do something to stop this? And we'll say, well, everyone else thought it was a good idea. I don't want to be too negative. But anyway, everyone just have a think about some of these issues and maybe have some more discussion in your tutorials. Okay, so I think we better wind it up now, and I'll see you next week. Ah, yes. Yeah, yeah.
CSC, and then I won't be able to access any of these folders unless I get to public HTML and kind of move in.
Oh, you managed to log in?
Yeah.
Oh, okay. Well, maybe at the beginning...
There's no access to any folders, so...
Oh, in your home directory. It sounds like you got into your home directory, but there just isn't anything in there.
Right, so where should I...
Well, I think well, there's two things. First of all, it's probably good to physically go to the lab and log in. That'll create some folders, but it may be just folders that configure the web browser and that sort of thing. But in general, I think you're supposed to create your own folders.
This is my general question.
Yeah.
If I access any of these computers in other libraries, will I be able to access lab computers remotely from...
Yeah, you should be able to remotely access the lab computers.
And would the lab will be open 24 hours in or do you reckon there's like limited hours access to it?
The labs, I don't... Is there a 24-hour lab? I think it's limited access. I don't know when they actually...
Alright, thank you very much.
I think Saturday and Sunday is
So on the weekend,
I think it's
it's okay? Okay. So
I'll check about that. I mean, when I say go to the lab, I mean, I think you should go to the lab just initially, but after that, you should be able to do everything remotely. And there is a way to... If you need a graphical interface, there's a way to set that up using Xming or VLab. Yeah, like I was just... you notice when I was using Emacs, I was actually just totally using a keyboard and not something else. But there is a way to link PuTTY to Xming, and then you'll be able to have a graphical interface. That's
I think the labs.
Yeah.
It's not compulsory.
It's not compulsory.
But I don't see the exact time before I can be there. The day or day.
4 to 8? 4, 8?
I'm sorry, I didn't see that.
So
4. Yeah.
you can go any time between 4 and 8.
4 and 8. Yeah. And for the tutorial, I can ask what's going to be. I didn't see any questions.
Okay. Have you logged into Open Learning yet, or?
Yes, but there's only.
Okay. Sorry. Yeah.
There's only tutorial answers, which is not available right now.
But because I have
This,
a,
sorry, I should have
tutorial,
said
this-
you've got to click on this tutorial here in each module.